Today we're going to cover sets, probabilities, permutations, and combinations. Okay. So, to start off, these are the sets. The topics we're going to cover today: sets, subsets, proper subsets, operation on sets, intersection of two sets, union of two sets, disjointed sets, Venn diagrams, and a little bit of an introduction to probabilities and basic concepts of probability. For next week, we're gonna overlap because I believe next week I'll be covering more in detail the probabilities. For next week, okay. But for today, let's get started with the topic of sets. Before we do examples, we have to cover the definitions of sets. This section has a lot of definitions that you have to keep in mind. Okay, a set is a well-defined collection of objects. Examples of sets. These are well-defined collection of objects. For example, all the students in my math class. You see is well-defined, and the students are objects or elements. Or letters in the alphabet. Those are two examples of well-defined collection of objects. Now this one here, guys, the collection of young adults is not well-defined. Why? Because what's considered young adults? So that's not a set. But let's rewrite it so it can become a set. The collection of young adults between the ages of 18 and 29. Now this is well-defined, right? Because this is from the ages of 18 to 29 is what we consider young adult. So now this is a set. Okay, now capital letters such as A, B, C, and so forth, they're used to name sets. Each object in a set is called a member or element of the set. And a set is enclosed by those braces or those curly brackets. They're used to enclose objects in a set. Let's give some examples. Okay, this is A, right? So this is considered set A, has the elements of 3, 4, 5. And this symbol, like the upside down E, or the symbol that looks like an E, it means it's an element of the set. And the symbol with a line over it, it means it's not an element of the set. Example. Say we have the set A equals to 3, 4, 5. Okay, now 3 is an element of A, which is true, right? Because 3 is an A, or the set A. Or 3 is an element of the set 3, 4, 5. You see the symbol makes it that it means that this symbol is set A. And here's how you read it. The first one, 3 is an element of set A, or 3 is an element of the set containing 3, 4, and 5. Now, 2 is not an element of set A, or 2 is not an element of the set containing 3, 4, and 5. Because all this means is 2 is not in A. 2 is not in the set A. That's what it means. And here's how you read it, or how you say it. The one on the left, it is 2 is not an element of set A. The one on the right, 2 is not an element of the set containing 3, 4, and 5. Now, what's an empty set? An empty set has no elements, and here's its notation. You can represent it with a symbol of like a 0 with a slash over it. That means empty set, or the brackets, the curly brackets with nothing in there. These two are two ways to describe an empty set. Another mistake that students make is that they want to put the symbol, the 0 with the line over it inside the bracket, and that's wrong. It's either this is the symbol, or this is a symbol, not one inside the other. So it's either the one on the left with a circle, or the O with a line over it, or the curly brackets. It's either one or the other. Equal sets. Equal sets contain exactly the same elements. Example, 3, 4. The set 345 is equal to the set 543 is equal to the set 435. These are all considered equal sets. Now, sometimes we describe a set by common properties of its elements rather than by a list of its elements. This property can be expressed with a set builder notation. Okay, and this is, okay, here it is. This is how you read this property here. The set of element x such that x has a property of p. Let me break it down for you guys. The set, right? The set of elements of x. The line like that, this line here, guys, means such that x has a property of p. This is broken down in detail. That's how you read this. Okay, example. It says, list the elements in the given set. It says, the set x such that x is a natural number more than 5 and less than 8. The answer will be 6 and 7, right? Because more than 5 means it cannot be 5. And less than 8, it cannot be 8. So this is my result. The set containing the elements 6 and 7. Now look at B now. Okay, let me go back real quick. Look at B. It says the set x such that x is an integer and is between -3 and 1, or x is more than -3 and less than or equal to 1. Guys, integers are all the numbers from negative infinity to positive infinity. Okay, and they have to be like numbers, like no fraction or nothing, just numbers. Those are integers. This will be the set -2, -1, 0, and 1. This is my result. Okay, now there's things that you have to keep in mind here. You need to know this. Whole numbers, they start with 0 and they go all the way to infinity. Counting numbers, they start with 1 and go all the way to infinity. Natural numbers are counting numbers. So this is something that you guys need to know. For example, on A, right, on A here, it says list all the given numbers, right? So, natural numbers, you have to know that they start with 1 and they go to infinity. But in this case, it didn't make a difference, right? Because it just said that it was from 5 to 8. Okay, now let's do more examples here. Okay, these come straight from the homework. Okay, here, guys, you have to state either if it's true or false. Okay? Number 1, 3 is an element of the set 2, 5, 7, 9, and 10. This is strictly false. Why? Because 3 is not in the set. Okay? And this is the reason why 3 is not an element of the set. 2 is an element of the set 2, 5, 7, 9, and 10. This is true because 2 is in the set. This is true because 2 is an element of the set. Number 3, 6 is not an element of the set containing 1, 3, 5, 6, 7, and 1, 3, 5, 7, and 9. This is true, right? Because this is saying that 6 is not in there, and it's true. 6 is not an element of the set. 4 is not an element of the set containing 2, 4, 6, 8. This is false. Why? Because 4, it is in the set. And this symbol means that it's not. So this is false. Number 5. The set containing the elements 1, 2, 3, 4 is equal to the set containing the elements 4, 2, 3, 1. This is true because every element on the first set is also on the second set. They're equal sets. Now look at 6. The set containing A, B, and C is equal to the set containing A, B, C, D. This is false. Why? Because the first set is missing the D. For them to be equal sets, they have to have exactly the same elements. Okay. Now, let's look at number 7. The set of all the whole numbers greater than 5 and less than 9. Okay. greater than 5, which would be 6, 7, and 8. So this has to be true. Okay? Because the numbers greater than 5 is 6, 7, 8, 9, 10, 11, 12, right? But here's another condition that it has to be less than 9. So 6, 7, and 8 is a set. I mean, the set containing 6, 7, and 8 is true. Okay. Now look at this one here. All the natural numbers not greater than 4. Right? This, guys, is going to be false. Why? Because 0 is not a natural number. The natural numbers, they start with 1 and they go all the way to infinity. So in this case, all natural numbers not greater than 4 has to be only 1, 2, and 3. Number 9. Let me go back real quick. Number 9. It says, the set containing the elements of x such that x is an even integer between 5 and 19. And if you notice, this means x is more than or equal to 5 and x is less than or equal to 19. So it has to be an even integer, right? So we have 6, 8, 10, 12, 14, 16. We're missing the 18. So this has to be false because 18 is not there. Okay. Look at number 10. The set with elements of x such that x is a vowel. This is true because all the vowels in the alphabet are A, E, I, O, U. That's true. Okay, all the vowels are listed. Hey guys, these are actually some of the homework problems from this section, or from this chapter here, from the section of sets. Now comes more definitions. Right? Subsets and proper subsets, and also universal set. The universal set is a set that contains all the objects being discussed or considered. Subsets and proper subsets. Hey guys, here. A set A is a subset of set B, and this is how you write it. A is a subset of set B, provided that every element of A is also an element of B. And a set A is a proper subset of set B, written as A with a symbol, right, with that symbol. A is a proper subset of B if every element of A is an element of B, but B contains at least one element that is not in A. When A contains an element that is not in B, then A is not a subset of B, and we write it as A is not a subset of B. Now, when I was taking this course back in the early 2000s, this was kind of confusing to me because I had never, I remember having this in high school. I probably did, but I didn't remember. But anyway, guys, I wrote the rules in an index card. And every time I had to do something for the homework, right? Determining if it was a subset or proper subset, I would take out my index card with having the definitions until I learned it. Okay, because this can be a little bit like a little bit confusing because the symbols are almost the same and all that stuff. So if I was you guys, I would get an index card and try to put the rules there. But let me show you examples. That way you know exactly what a subset is and also a proper subset. Okay, here we go. Also, for any set A, empty set is a proper subset of A, or the empty set is a subset of A, and A is a subset of itself. A is a subset of A. Examples. We have set A has the elements of A, B, and C. Set B has the elements of A, B, C, D. And set C has the elements of C, A, B. Okay? Now, these are all true here, guys, okay? But let me tell you why. It says A is a subset of B. Okay, let's look at the definition here and see why. It says set A is a subset of set B, provided that every element of A is also an element of B. You see, guys, every element in A, B, and C is also in set B, A, B, and C. That's why this is, all these are true. Okay, but this one, I mean, that's true. Look at the second one, right? A is a proper subset of B. That's also true. Why? Because as we read it, it says set A is a proper subset of set B if every element of A is an element of B, but B contains at least one element that is not in A. Okay, you see, guys, every element in A, in set A, ABC is also in set B, ABC. But you see, here's the but B contains an element, at least one element that is not in A, which is my D. Okay, let me go back. Hold on, let me go back here. Now, hold on, let me. Now let's do B. I mean, let's do C. It says B is not, right? The line B. I mean the line crossing the symbol, the proper subset symbol. It says B is not a proper subset of A. That's true because every element of B is not in A. You see, guys, B has A, B, C, D, and A has A, B, C. Every element in B is not in A because the A is missing the D. Now look at D. A is a subset of C. That's true, right? Because every element in A, which is A, B, and C, is also an element of C, which you have C, A, B. So that's true. Now look at E. A is not a proper subset of C. That's true because A is not a proper subset of C because they're equal sets. Anyway, if we look at the definition, right, it says here, a set A is a proper subset of set B, right? If every element of A is an element of B, but B contains at least one element. Check this out, guys. You see, so every element in A is also in C, but C does not contain an element that is not in A. That's why this is correct. Now F. Remember, guys, the definition is here for any set. The empty set is a subset or proper subset of any set. You see, so the empty set is a proper subset of A. So all these are true statements. Okay, now this is from the homework now. On the homework, it gives, let A have the elements -4, 0, and 4. And set B has the elements -3, -2, -1, 0, 1, 2, and 3. And set C has the elements of -4, -1, 0, and 4. And set D has the element of 0. And set E has the element of -4. And this is my universal set, right? The U stands for universal set. The universal set has the elements -4, -3, -2, -1, 0, 1, 2, 3, 4. Now for this part of the homework, they want you to insert either proper subset or not a subset. Remember, this symbol means proper subset, and this symbol here, guys, right? I mean, without that slash over it means subset, but with that line over it means not a subset. Okay, now, so here, guys, we have to enter the symbol. Let's call it symbol number 1, which is a proper subset, or let's put symbol number 2. I'll call it symbol number 2 for simplicity. This symbol here, guys, means it's not a subset. Let's go here, right? We have A. It has the elements -4, 0, and 4. Let's go to the universal set. You see it has the -4, the 0, and the 4. So the first symbol goes in there. And here's the reason why. Okay. Every element of A is an element of U, but U contains at least one element not in A. Number 12. E, we have E is -4. The set contains -4. And A is -4, 0, and 4. So this is the first symbol, which will be the proper subset. Because every element of E is an element of A. But A contains at least one element, which is the 0 and the 4. Now, this is number 13. We have A, -4, 0, and 4, the set with -4, 0, and 4, and we have E. negative 4. So this has to be the second symbol there. It's not a subset, because every element of A is not in E. Elements 0 and 4 are not in E. Number 14, we have B and C, right? Let's see. So does every element in A is in C? No, right? That means it's going to be the second symbol, which is not a subset. And every element of B is not in C. The elements negative 3, negative 2, 1, 2, and 3 are not in C. That's why it's the second symbol, which is not a subset. For 15, right? 15 is going to be the first symbol, because every empty set is an element of any set. Number 16, we have the set containing 0 and 1. Let's go to D. D only contains a 0. So this is the second symbol, because the set containing 0 and 1 is not, all the elements there are not in D, because D is missing the 1. So that's the second symbol. Okay, but if we reverse it, it's going to be the first symbol. Why? Because every element in D, which is a 0, is also an element of the set containing 0 and 1. So it's going to be the first symbol, which is a proper subset. Now let's do D and B. Let's take a look at D, which has the element of 0, and B has the element negative 3, negative 2, negative 1, 0, 1, 2, and 3. This will be the first symbol, because every element in D, which is a 0, is in B. Now let's do A and C. A is negative 4, 0, and 4, and C is negative 4, negative 1, 0, and 4. So this is, let me see here, this is the first symbol. Why? Because every element in A is also an element of C. And C contains a symbol, an element which is negative 1, which is not in A. Okay. And so hopefully, guys, that made some clarification here, but these are all from the homework. Okay, now here, guys, we have to list all the possible subsets given sets. Okay. Recall, a set A is a subset of set B, right? And this is how you write it, provided that every element of A is an element of B. So solution, right? We have the set 4, 6. So how many subsets can we get? Right, so we know the empty set is in every set. We know that the 4, right, the set containing 4 is also a subset of the set 4, 6, because the 4 is in there. And then the 6 is a subset, the set containing 6 is a subset of the set containing 4 and 6. And then comes the set 4, 6 is a subset of the set 4, 6. So we're going to have, right, so this is my list. And they tell them to list them, this is the listing format. But at times, they're going to want you to find how many are there. Okay, and for that, this is going to be like a formula that we're going to that I'm going to explain after I explain the next example. Okay, I'll say with 2 elements has 4 subsets. 1, 2, 3, 4. Let's do B, right? So the easy way to do it, guys, how I tell my students is that you always start with the empty set. And then you're gonna get a set one at a time. For example, set A, set B, and set C, and then in pairs. So you see, so there's my set A is in there, set B is in there, and set C. Now we do them in pairs and choose, right? So it'll be AB, it'll be AC, and BC. And then we put them all in there. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8. That's a list. A set with 3 elements has 8 subsets. And here's the formula. Okay. It says a set of n distinct elements has 2 to the power of n subsets. For example, right here, right? Then we have 2 elements. So 2 to the second power will give us 4. And example B, we had 1, 2, 3 elements, right? So 2 to the third power will give us 8. So let's find, for example, 20, 21, and 22. It says find the number of subsets of the given sets. if you notice, guys, it says find the number. It doesn't say to list them. So find the number, guys, we're going to use the formula here. So the answer would just be 2. Why? Because if you have one element, we raise it to the first power, which will be 2 subsets. Look at 21. We have 3, right? So n will be 3 because we have 3 elements. So it's going to be 2 to the third power is equal to 8. Number 22. The set with elements x such that x is a whole number less than 5. Remember, guys, the whole numbers means 0, 1, 2, 3, and 4. So it's going to be 5 elements. So we raise it 2 to the 5th power will give us 32. So this will have 32 subsets. And again, on the homework, at times it says to list them, and at times it says to find the number of subsets. Okay, now this is called operation on sets. Given a set A and a universal set U, the set of all elements of U that do not belong to A is called a complement. The complement of A is written as A prime, or you can say A naught, or not A. Example. Say you have the universal set. You have the numbers from 1 to 12. And set A has the numbers, the elements 1, 2, 3, 4. Okay, so let's do a Venn diagram here. Right, this is U means all the elements being considered, right? That's what it means, this rectangle. And this is set A. And what's on the outside is the complement of A, which is not A. You see, that's what that means. The complement of A is the same thing as not A. So find the complement. Okay. So let me go back real quick. Because this is what it means. So not A means, okay, this means the complement of A, or not A means I'm going to go to A, right? So I'm going to go to my universal set. A means not 1, not 2, not 3, and not 4. So not A means it's going to be 5, 6, 7, 8, 9, 10, 11, 12. That's your result. That's the answer. Okay, now how do we do that in a Venn diagram, guys? This is called a Venn diagram. How do we represent that in a Venn diagram? Okay, this is my universal set. This whole thing here, the rectangle. This is set A. So set A contains 1, 2, 3, and 4. That's set A. And not A, or the complement of A, means the 5, 6, 7, 8, 9, 10, 11, 12 will be in the outside, but they're in the universal set. So there's 5, 6, 7, 8, 9, and 10. That's how you write, or that's how you represent a Venn diagram with this given information. Right? But we're missing the 11 and the 12. Okay, that's how we do it. Okay, now, intersection of two sets means and. Given two sets, A and B, the set of elements belonging to both set A and B is called the intersection of the two sets. And this is how you write it. A, right, with the and symbol, right, which means elements belonging to both sets. But I like to make it clear to students at times, because at times students, they don't know the vocabulary. So this is an easy way to remember. What do they have in common? Okay. So for example, this is my universal set. It's the numbers from 1 to 12. Set A is the numbers 1, 2, 3, and 4. And set B are the numbers 2, 4, 6, and 8. So find A intersects B. So I'm going to go to A and B, right? What do they have in common, A and B? They have a 2, right? They have a 2. And they have a 4. So that's your answer. The element containing 2 and 4. Okay, now let's represent that with a Venn diagram. There's my universal set. This is set A. This is set B. And the intersection will be right here, guys. That means intersection right there. That's A intersects B. Now, let's give this given to give us this example. Let's put it as a Venn diagram. This is my universal set, right? First, we start what they have in common, right? Which is the 2 and the 4 start here. You always start where they intersect. And then, right, then we go to set A. A contains 1, 2, 3, 4. The 2 and the 4 are already here. So we got to put the 1, right? To say we got to put the 1 and the 3. So this is set A, right? Because it has the numbers 1, 2, 3, and 4. And set B, right, has 2, 4, 6, 8. So what's missing, we got the 2 and the 4. So the 6 goes in there and the 8 goes in there. But we're not done yet. Because what happens to all these numbers here? So they're not in set A and B, right? So we have to put them outside of set A and B. The 5 goes there, the 6, the 7, the 7, not the 8 because the 8's already in there. The 9, the 10, the 11, the 12, and that's it. This is how you represent the Venn diagram with this given information here. Okay, now, hey guys, disjointed means that they don't have nothing in common. They're separate. It says here for any sets A and C, if A and C are disjointed, it means that there's no intersection. The intersection of A and B, of A and C, there's nothing in there. That's why it's the empty set. Okay, same set of numbers for set U, set A, and set B. Now we added C. C contains the elements 5, 7, 9, and 11. So A intersects C. What does A and C have in common? They have in common, right, nothing, because A has 1, is not in C. A has the element 2, is also not in C. 3 is not in C, and 4 is not in there either, so they have nothing in common. So it's the empty set. And here's how you explain it with a Venn diagram. There's universal set. That's my set A, and this is my set C. You see, guys, there's no intersection. That's why it's called disjointed. Now, how do we represent that with a Venn diagram? There's my set U. There's my set A, right? A contains 1, 2, 3, 4. This is my set C, and C contains 5, 7, 9, and 11. Now what's in the universal set, but it's not in both sets, is going to be, right, the 6 is missing, the 7 is already in there, the 8, 9 is already in there, the 10, the 11 is already there, and the 12 go in the outside. This is your result. Okay, union of two sets. Union of two sets is the OR. The OR means union of two sets. Okay, given two sets, A and B, the set of elements belonging to set A or B is called the union of the two sets. And this is how you write it. A with the upside down looks like a U, and the B. That means OR, or union. Okay, now, here's another way to explain it. I just put, you list elements of both sets, but do not repeat them. Okay, I'm going to show you an example of that. Again, we have the same information from before. The set U contains the elements 1 through 12. Set A contains the elements 1, 2, 3, 4, and set B contains the elements 2, 4, 6, 8. It says find U, find A union B. Okay. So here's how you do it, guys. You're going to write everything in A, right? Everything in A, which is 1, 2, 3, 4. And then we go to B, and then we begin writing B, right? But if it's already there on B, we don't put it twice, right? Is the 2 already there? Yes. So we don't write it again. Is the 4 there? Yes. We don't write it again. Is the 6 there? No. So we're going to include it. Is the 8 there? No, we're going to include it. So this is my result. And again, you list all the elements of both sets, but do not repeat them. I always start with the one that they give me first. I put all the elements there, which was a 1, 2, 3, 4. And then I go to the other set, being considered, which was set B, and if the element's already in there, you don't put it twice. And then the elements that are not there, you do put them in there. And here's how you represent that. This is my universal set. This is set A, set B. Set A union B means all this right here. That's what it means, everything. Okay, now let's represent that with a given information here. Right? So first we start for the intersect, which was the 2 and the what was the 2 and the 4, right? The 2 and the 4. You see the 2 and the 4 is what's here first, right? And then the 1 and 3 go on the outside. Like if here, guys, I mean, how you started with for the intersect, which is 2, 4, and then you go to the set, the 1 and the 3, you're going to put them inside A, but not for the intersect. So for B, it's going to be the 6, and the 8 is missing. Okay, now, but there's two all the way to 12, right? That's part of the union. So we got the 1, the 2, the 3, the 4 was missing, the 5 is missing, so we got to put it in there. The 6 already there. The 7 is missing, so we're going to put it in there. The 8's already there. We need the 9, we need the 10, the 11, and the 12. That's going to represent the Venn diagram with this given information. Okay, now, it says, let A and B be any sets with U signifying the universal set. Then the complement of A is written as, right, A prime or not A. Right, so this is like a review really of what we covered up to this point. Okay, you see, so not A, right? This is A, this is not A. This is the intersection of A and B, right? That's the intersection. Now this is a union, right? The union contains everything in A and B. That's union. Okay, let me go back real quick. Okay, so this is what we covered right up to this point. The complement, which is not A, the intersection, and the union. Now these are from the homework. Okay. Okay, we have to find, right? They give us X, they give us a universal set, they give us X, Y, and Z. So we're going to need the complement of X and also the complement of Y. So that's it. X is A, B, 1, 2, 3. So the complement means not A, not B, not 1, 2, and 3. So whatever's left is the complement of X, which is C, D, E, 4, 5. Same thing with the set Y. The set Y contains B, D, 1, 3, 5. So not Y will be not B, not D, not 1, 3, 5. So it'll be the A, the C, the E, the 2, and the 4. So this is a set, not Y, or the complement of Y. And that's my set Z, right? Now, here we go. So for 23, X and Y, or X intersects Y, or what does X and Y have in common? So the X and the Y have in common what? An A? No. A B? Yes. A 1? Yes. A 2? No. A 3? Yes. That's my result. That's your answer. 24. 24. X or Y, or X union Y. Remember this one, guys? The union. The union is you're going to write them all down, but you don't repeat them. Okay, again, you're going to write them all down, but you don't repeat them. So for the X, I'm going to put everything in X, which is A, B, 1, 2, 3. Now I'm going to go to Y. Is the A already there? No. The B already there? Yes. Is the D already there? No. So I had to put the D. Is the 1 there? Yes. The 3 there? Yes. The 5 there? No. I got to put the 5. So this is my result. Okay. Now, for the complement of X, We already have it here on the right? So there it is. This is my answer from here. Okay.
Olivia Isassi.
Hey guys, hold on a minute. Okay, now let's do number 27. Number 26. X, not X intersects not Y, so it's going to be here on the right. So what does not X and not Y have in common? They have in common a C. They have in common an E and a 4. And that's the answer. Okay, now this is number 27. The complement of X intersects Z. So we have here, right, the complement of X. What does X and Z have? The complement of X and Z have in common, right? Let me see. The Z has a B. There's no B in the complement of X. There's no 2. There's no 3. So it's going to be the empty set. Okay. Now let's look at number 28. We have X union parentheses Y intersects Z. So we have to do the parentheses first. So what does Y and Z have in common? Y and Z. They have in common a B. Right? They have in common a B and a 3. And that's it. Now remember how we did the union? For the union, we're going to put everything in X first. Right? X has A, B, 1, 2, 3. And then we look at the Y intersects Z. And if it's already there, we don't put it twice. And if it's not there, we also include it. Is a B already there? Yes, it is right there. Is a 3 already in there? Yes, it is. So this is my result, guys. That's your answer right there. Okay. Now, here comes a Venn diagram with 3 sets. Let's go here. So from the Venn diagram, list the universal set U, set A, set B, set C, and the intersection of A and B, of A and C, of B and C, and the intersection of all 3. Okay, so there's my union. It contains A, B, C, D, E, F, G. That's my universal set. Right, now set A contains the elements A, D, E, G. Set B contains the element D, B, D, F, G. And set C contains the elements C, E, F, G. Okay, now here comes the intersection. What does A and B have in common, right? Or where do they intersect? The answer will be DG. What does A and C have in common, or where do they intersect? A and C. This is A here, A, right, and C. The answer will be EG. What does B have in common with C? This is B, this is C. The answer will be FG. Now the last one, what do they all have in common? The answer is G, right? Because that's what they all have in common will be this part here. That's my result for number 29. Okay, now comes this is also from the homework. It says 60 people were contracted and responded to a movie survey. The following information was obtained. 6 people like comedies, dramas, and science fiction. 13 people like comedies and dramas. 10 people like comedies and science fiction. 11 people like dramas and science fiction. 26 people like comedies. 21 people like dramas, and 25 people like science fiction. Okay, now here's what they want. For part A, use a Venn diagram to illustrate the survey's results. So in other words, we have to do a Venn diagram and then answers, and then after that, answer B, C, and D. So then here's how we do it, guys, okay? There's 60 people, right? So I'm going to start off here because there's 60 total. Now, let C be the set. Let's say C be comedies. So let's make that C. Let's let the set D equal to dramas. Here's my set D. And let S, the set S, be science fiction. There's my science fiction. Okay, now guys, how we start here, guys, we always start for what all three have in common, right? So start at intersection of all the sets, C, D, and S, right? The answer is 6. So that 6, guys, for they all have in common will be right here on this area here. That'll be my 6 right there. That's the answer right there. Now, right, 13 people like comedies and dramas, right? So we're going to get the intersection of C and D, right? This is C, and this is D. The intersection will be this part here, right? So we already have 6, so this has to be a 7 there, right? Because this is equal to 13. Now we do the intersection of C and S, right? There's 10. Comedies and science fiction. So comedies and science fiction will be, this is my C, my set C, and this is my set S. So 10 has to be right here, guys, right? This is the area where they both intersect. So we have a 6, right? There's already 6, so it has to be a 4. Now 11 people like dramas and science fiction. So we're going to do D intersects S, right? So it's going to be D and S. So this is D, and this is S. So the area that's being considered will be this area here. We already have 6, right? So this has to be 5. 5 goes there. Then we go to comedies, right? It's 26 people in comedies. So we go to set C, right? So all this has to be 26. We already have 4 and 6 is 10, plus 7 is 17. So we subtract 26 minus 17, so 9 has to be here, right? Because all this must equal to 26 on set C. Now let's see here. Now 21 people like dramas. So D equals 21. So all this area here, guys, the set D has to be 21. I already have 13. Well, I already have 18. So 21 minus 18 will give us 3. And finally, guys, 25 people like science fiction. So all this set S has to be 25. Right? We have 4, we have 6, that's 10, 15. So the answer will be 10. 25 minus 15 is 10. Now, we also have to consider how many people are in the are in the outside of the sets, but inside the universal set. So we have to count them all. Okay, this will be my X. So we have to add all the numbers, right? We have the 9, the 7, the 6, and the 4, plus 3, plus 5, plus 10, right? Gives us 44. So 60 minus 44 will give us 16. So X equals to 16. Okay, now guys, let's do here. Now this answer, that's the answer for A part right there. Now let's do B. How many people surveyed like comedies but neither dramas nor science fiction? Okay, let's go here. How many people surveyed like comedies, right? Like comedies, but neither dramas nor science fiction, right? So they're talking about comedies, but neither dramas nor science fiction. The answer will be 9. There's 9. How many people surveyed like dramas and science fiction? Okay, they like these two, right? Dramas and science fiction, but not comedies. So it's going to be, right? So dramas and science fiction, but not comedies is going to be only the 10, the 5, and the 3. It's going to give us 18. And finally, how many people like none of the movies will be what's in the outside, what's inside the universal set, but it's not included on none of the sets, which is C, set D, set D, set C, set D, and set S. So the answer will be 16. Okay, now guys, so now this is an introduction to probabilities. You got here, this is it's called a random experiment, which is a process by which we observe something uncertain. After the experiment, the results of the random experiment is known. Sample space, denoted by S, the set of all possible outcomes of the random experiment. Examples. For flipping a coin, right? For a coin flipping, sample space is going to be 2, right? Because it's either can be heads or tails. For another example, for rolling a fair die, the sample space will be 1, 2, 3, 4, 5, or 6 because a die has only 6 sides, numbered 1, 2, 3, 4, 5, and 6. So this is my sample space. Okay, now to find the sample space of an experiment at times, it's easier to draw a tree diagram. Example, find the sample space of flipping a coin twice. Okay, flipping a coin twice. This is my first flip. It can be heads or it can be tails. My second flip, it can be heads or it can be tails. My second flip, right, if it was tails first, it could be heads or it can be tails. So here's my sample space. It's going to be heads, 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 tails, tails, heads, and tails, tails. So my sample space will be HH because H stands for heads, HT, TH, and TT. Now, an event is an outcome or a set of outcomes of a random experiment. An event is a subset of a sample of the sample space. It gets, I'm sorry about the phone. It just keeps ringing. I try to put it in an off ring. For example, if the space of flipping a coin is S is equal to, the sample space is H and T, right? Then one event is H, which represents the outcome heads. Checkpoint. Suppose a die is tossed. Write the given events and set notation. Okay? There's my sample space. For A part, the number showing is less than 3. So it's going to be 1 and 2. Right? Because it's less than 3. For B, the number showing is a 5. So, it'll just be the set with a 5 in there. For C, the number showing is an 8. There's nothing, it'll be the empty set because there's no 8. It's only 1 through 6. The die showing, the die shows an even number. It's going to be 2, 4, and 6, right? The set containing 2, 4, and 6. Okay, now guys, let's stop there. The reason why, because this, I will explain it next week. Because up to this point, it was only like and maybe like a little introduction to probabilities. But let's stop there, guys, because this part of the presentation is where I'm going to explain it next week. Okay. So let me end the show. Let me take it back to the host, and that way they can explain what's going to happen next week. And again, I repeat, next week I'll be going over I believe the last 2 slides, and that's what I'm going to be starting. Okay.
Thank you, Mr. Isasi.
You're welcome.
Thank you for your great presentation. We want to remind you that all our previously recorded sessions are available on YouTube on the Tejano Virtual Events playlist. This session will also be available on the playlist later today. Also, linked is a short survey to help us improve our Tejano Virtual Events sessions. Please take a minute to fill that out. And before you leave, I do want to share the Tejano Virtual Events flyer with the sessions we will be having next week. At 1 p.m. today, we will have the EPCC Honors Program. And next week, we will have, at the Math 1314, we'll be covering inverses and determinants and matrices. And for the Math 1324, we will cover basic concepts of probability, permutations, and combinations. Thank you all for coming today, and we do hope that you all have a lovely weekend. If you have any questions, please feel free to use the chat box or your mic, and we do hope to see you again for Happy Math Hour next week. Thank you.